When using bisection method in trigonometric functions, the common unit used is in radians. Check out this example here in numerical solutions to see problems. Before delving with an example, let's differentiate bisection from the previous method first. Say that we have a curve drawn on the Cartesian plane, where the root is as indicated. When we were working on incremental search method, we actually have to divide the interval into desired increments and compute in order to know which smaller interval to use in the next iteration. Although admittedly, this method is simple, it is time-consuming, so the bisection method shortens the procedure a little bit. In this approach, the concept is to cut the interval into half and totally disregard the irrelevant half. So we take x of 0.5 and then drop the first half as the root is found on the second half anyway. We are to use bisection method in figuring out the root of the function 2x cubed sine of x squared less 5x minus 3. The root we are looking for is near the origin, and it is on the negative side. Sine will be solved using radians, and we are only to stop iterating if we achieve 4 decimal accuracy, after using whole numbers for initial values. The instruction is a guide on which values to use initially. Nearest the origin, we use x of 0. The function then becomes twice of 0 cubed with sine of 0 squared minus 5 of 0 minus 3. The result is negative 5. Assume a negative number this time. Say we take negative 1. The function then becomes 2 times negative 1 cubed with sine of the square of negative 1 less 5 of negative 1 minus 3, which results to 0.3171. We already have a sine jump. Illustrating these values, we can see that at x of 0, y is below the axis at negative 5. But when x is negative 1, y goes up to positive 0.3171. So the assumed curve looks like the one shown. In using the bisection method, we are to take the midpoint. But before that, mark the limits as positive for x of negative 1 and negative for x of 0. The marks are based from the y locations of the points. When we bisect, we start off by taking half of the x interval, and that is 0 plus negative 1 upon 2, which is negative 0.5. Have this placed into the function and get twice of negative 0.5 cubed times sine of negative 0.5 squared minus 5 of negative 0.5 minus 3. This gives negative 0.5619. From the graph, we can then verify that the root seems to be somewhere within the first half of the interval. So disregard the second half as we move the negative limit to negative 0.5. Illustrating intervals will take time, but as long as we identify the marks, it would be easier and faster to iterate using a table. The most important columns for the table are the left and right limits, the midpoint, and the y location of the midpoint. And from the first computation earlier, we have the left limit as negative 1, the right as 0. Their midpoint was computed as negative 0.5, and the function of this midpoint is negative 0.5619. The first iteration was completed, So we continue on to the next, starting from noting the sign of f of c, where in this case is negative. The negative f of c means that c replaces the negative limit, which from the illustration, we marked this earlier as b, or the right limit. The left limit remains the same at -1. After completing the first two columns, we complete the rest of the iteration by taking the midpoint, and that is by the average of -1 and -0.5, which is -0.75. Use this value in the function to have twice of -0.75 cubed with sign of -0.75 squared minus 5 times -0.75 less 3, which brings about positive 0.30003. This completes the second iteration. F of c is our guide in reaching the accuracy, and since it is far from 0, we continue on the next iteration. So again, check the sign of f of c, which is positive. The positive sign indicates that c replaces the left limit, and b remains at -0.5. The third column is solved as the average of a and b, which is -0.625. Then, these values plugged into the function and get twice of -0.625 cubed, sine of -0.625 squared, minus 5 of -0.625 less 3. The result is -0.06092. This early, we already achieved the first decimal zero. The fourth iteration starts similarly like the others. Check the sign of f of c, which in this case is negative. This means that c replaces the right limit, and a stays the same at -0.75. The midpoint is then taken as the average of -0.75 and -0.625, which results to -0.6875. Use this value into the function and have 2 times of -0.6875 cubed, sine of -0.6875 squared, minus 5 times of -0.6875 less 3, giving positive 0.14163. The next iteration starts with c replacing a this time. It is because f of c is positive. b remains at -0.625. c is then computed as half of -0.6875 and -0.625, which is -0.65625. Having these into the function makes it 2 times -0.65625 cubed, sine of the square of -0.65625 less 5 of -0.65625 minus 3. F of c is then taken as positive 0.04527. Keep on completing the next iteration, as the accuracy hasn't progressed yet. Positive f of c means that c replaces a and b remains the same as 0.625. With a and b already identified, take their midpoint with half of -0.65625 plus -0.625, giving -0.640063. Use this value into the function and arrive at -0.00667. Finally, we are at double decimal accuracy. For the next iteration, checking that f of c is negative, c replaces b, and a is still -0.65625. Their average is taken as half of -0.65625 and -0.64063, which makes -0.64844. Place this value into the function and have twice of negative 0.64844 cubed with sign of negative 0.64844 squared minus 5 of negative 0.64844 less 3. This is simplified as positive 0.01961. Iterate further. Having positive 0.01961, C replaces A, while B still remains at negative 0.64063. The third column then is half of the first and second, which results to negative 0.64454. Place this value for x in the function and get 2 times of negative 0.64454 cubed with sign of negative 0.64454 squared minus 5 of negative 0.64454 less 3. The result is positive 0.00655. Another 2 decimal zeros. Let's attempt another to reach the accuracy required. With a positive sign of f of c, a becomes negative 0.64454. B is still negative 0.64063. The midpoint of these two limits is solved with half of negative 0.64454 plus negative 0.64063, which is negative 0.64259. Have this value placed into the function as substitute for x, and get positive 0.000022 as f of c. Note that these already showed 4 decimal zeros, which is even more than the accuracy, so we can end the iteration and take the root for the function as negative 0.64259.